Hello, welcome back to this lecture over here. So for today, I'll be covering your kinematics chapter, which is required for your WA as well as your end of year exams as well. So for kinematics, this chapter is maybe a bit tedious at the start, but once you get used to it, it should be okay. So let's get started. So the first thing that I'll be covering is your displacement versus your distance. So what's the difference between your distance as well as your displacement? So think of your displacement as just the distance from one point to another. So for example, let's say I got something like this. So my total distance will be 10 plus 7, which is 17 meters. But my total displacement will just be from the start to the end, which is this distance over here. So this one will be square root of 10 square plus 7 square, which is square root of 149. So this will be your displacement over here. So next one, if let's say I travel to the right by 10 meters, and then I travel to the left by 15 meters. So my total distance traveled will be 10 plus 15, which is 25 meters. But my total displacement traveled will be from the start, so this is the start point, and then to the end. So this distance over here, which is just 5 meters. So your displacement in this case will be 5 meters to the left. So for your displacement, it is something called your vector quantity. I'm sure you've learned what a vector quantity is in the last chapter already. And your distance is a scalar quantity. So for displacement, you need to make sure that whenever they ask for the direction in the question, you will have to tell them the direction as well. So 5 meters to the left. Next portion. So speed is the rate of change of distance, and speed will be distance over time. This one I'm sure you've learned it in primary school as well as your lower sec as well. So the difference between your speed and your velocity is your speed is the rate of change of distance, whereas your velocity is the rate of change of displacement. So when you're trying to calculate your velocity, it will be displacement over time. So let's say I have a man, he takes 10 seconds to travel this whole journey over here. So what is his speed and what is his velocity? So the total distance traveled for this entire journey will be 25 meters, and the total time taken will be 10 seconds. So his speed for this entire journey will just be 25 over 10, so it will be 2.5 meters per second. But for this entire journey, his total displacement will just be 5 meters, and his total time taken is 10 seconds. So his velocity will only be 0.5 meters per second, because the displacement is from the start to the end, which is this distance over here, making it 5 meters. That's all. Alright, so next one over here is acceleration. This one I'll be covering it in more detail later, but acceleration is just your rate of change of velocity. So it will be final velocity minus your initial velocity over time. This one, don't worry, I'll be covering with you later on. So let's move on. So this one over here, so as I mentioned earlier, your displacement is a vector. So if velocity is displacement over time, then velocity is a vector quantity as well. So for vector quantities, you will have to make sure that you indicate the direction as well. So for your velocity, the way to indicate your direction is by using a positive or negative sign. So let's say if I have plus 10 meters per second of velocity versus minus 10 meters per second of velocity. So the difference between them is not that one travels negative 10. It is just trying to say that maybe this guy, he travels to the right, but this guy, he travels to the left. So the negative and the positive sign in front of your velocity indicates the direction. So let's say if traveling to the right is positive, then when I travel to the left, my velocity will be negative. That's the idea behind the positive and the negative signs. So let's say I have two bodies over here, A and B. A and B are both traveling at a speed of 5 meters per second. And then let's say the motion to the right is positive for this first portion over here. Then my velocity of A will be 5 meters per second, whereas my velocity of B, because it travels to the left, it will be negative 5 meters per second. So that's the difference between them. So if I indicate my direction to the left as positive, then my velocity of A will be negative 5 meters per second, and then my velocity of B will be positive 5 meters per second. So as you can see, the positive and the negative sign is very much dependent on what you indicate as positive. Next portion over here. So initially I have this bus, he's traveling towards the right at 10 meters per second. So this one over here is trying to tell you that right is positive. So if let's say he travels to the left at 10 meters per second, his speed will be unchanged. So it will be 10 meters per second as well, but his velocity will become negative now because it is opposite in direction. Next portion. So this portion over here is the acceleration formula. So just now I briefly mentioned that your acceleration is your final velocity minus your initial velocity over your time taken. So over here you have A equals to V minus U over T. So V is your final velocity in meters per second. U is your initial velocity in meter per second as well. And then your time taken will be in seconds. So make sure when you are including your final and your initial velocity as well, if there is a direction change, then you need to make sure that you include your positive or your negative sign as well. So I'll get into what that means later on. So this one over here, a man travels from 40 meter per second to 80 meter per second in 4 seconds. What is the acceleration of this man? So this one is very easy. So he has an initial velocity of 40 meter per second and he has a final velocity of 80 meter per second. And then the time taken will be 4 seconds. So this one, all you need to do is just use the formula. So A equals to V minus U over T, which is 80 minus 40 over the time taken. So this one over here will be 10 meter per second squared. So make sure when you are using your acceleration, make sure when you're writing your acceleration, it is in meters per second squared. Next one. So a man travels at 40 meter per second to the right. After 4 seconds, the man travels at 80 meter per second to the left. Find the acceleration of this man. So when you're trying to find your acceleration, if there is a direction change, you need to be able to indicate which direction is positive first. So maybe we indicate rightwards as positive. So if rightwards is positive, then your initial velocity will just be 40 meter per second. But your final velocity, which is this 80 meter per second, it will be negative 80 meter per second because the motion is to the left. So if we were to calculate the acceleration, it will be V minus U over T. So it will be negative 80 minus 40 over the time taken. So it will be negative 120 over 4, which is negative 30 meters per second squared. So if let's say I take left as positive. So if I take left as positive, then what happens? So my acceleration will be 80 minus negative 40 over the time taken. So it will be 30 meter per second squared. So as you can see, the numerical values will be exactly the same. The negative and the positive signs only indicate the direction. So in this case, your acceleration is acting towards the left because the left side is positive. Next portion over here. So I have a car, he travels 20 meters in the eastward direction and then 15 meters in the westward direction. So it's something like this. 20 meters eastward and then 15 meters westward. So it takes 20 seconds to complete its journey. So your average speed formula, you need to know, your average speed is the total distance over your total time taken. So in this case, your total distance will be 35 and then your total time taken will be 20, making it 1.75 meters per second. This one should be quite straightforward. Next one is your average velocity. So your average velocity will be a very similar formula. You just have to change the total distance to total displacement over total time. So what is the total displacement of this man? So if he travels 20 meters eastward, means to the right, and then he travels 15 meters to the left. So your total displacement will be from the start, which is over here, to the end point, which is 5 meters in total. So your total displacement, when you put it into the calculation of your average velocity, will be 5 over 20. So it will be 0.25 meters per second. So as you can see, your velocity and your speed, they differ because the displacement and the total distance, they both differ as well. So let's say if I have another example, so let's say I have a man, he goes around this circle. So and this circle has a length of maybe 50 meters. So after one round, what is the average velocity after one round? So the average velocity after one round will actually be 0 meters per second. So why is it 0 meters per second? Because the total displacement that this man has moved is 0 meters. Because he start here and then he end here as well. So the total displacement is 0. So your average velocity will be 0 as well. Next one. So this one over here is the difference between your acceleration and your deceleration. So if your acceleration is 2 meters per second square, then your deceleration is simply just negative 2 meters per second square. So they are the opposite of each other. So if let's say my deceleration is 2 meters per second square, that means that my acceleration is negative 2 meters per second square. That's all. So you just flip the signs. Next one. So this portion I'll be covering with you is your gradient. So for your gradient, you learned it in Sec 2 as well as Sec 3. So your gradient is rise over run. So it will be this portion, which is your rise over your run. So for your gradient, there are a few things that you need to consider. So you need to consider whether or not your gradient is upslope or downslope. So if it's upslope, that means that your gradient is positive. And then if it's downslope, that means that your gradient is negative. Next one. So if your gradient is a straight line, what can you say about the gradient? So that means that your gradient hasn't changed. Think of your gradient as the steepness of the line. So if the steepness doesn't change, that means that your gradient remains constant. So this applies for all your different straight lines. So whenever you see a straight line, your gradient remains constant. Next one will be for curves. So for curves, your gradient may increase or decrease depending on the scenario. So this portion over here is important because you need to know how to describe your line, your gradient, as well as your area under the graph. So when you're describing your line and your area, you need to talk about the rate as well. So you need to be able to know what the rate is. The rate of increase is or the rate of decrease. Whereas for your gradient, all you need to say is your gradient is either increasing, decreasing, or constant, or 0. That's all. So for this first graph over here, your gradient is constant because it is a straight line and your gradient is positive. Next one. So if it's a horizontal line over here, there is no rise. So if there's no rise and your gradient is rise over run, then your gradient is just 0 in this case. Next one. So think of your gradient as the steepness of the graph. So as you can see over here, the graph is getting steeper and steeper and steeper. So your gradient is increasing. And because it is sloping upwards, your gradient is positive. Last one over here. So as you can see, the graph is becoming more and more gentle. So as a result, your gradient is decreasing and your gradient is positive as well because it is sloping upwards. So gradient is decreasing and gradient is positive. Next one, it will be for the description of the line itself. So what can you say about this line? So let's say at t equals to 1 versus t equals to 2. What happens to the value over here? So the value over here, right, is increasing at a constant rate. And how do you know it is a constant rate? So this one over here, right, is basically just the description of your gradient. So it will be increasing at a something rate. And this one over here is the description for your gradient. So if your gradient is constant, then this one will be increasing at a constant rate. So let's see if this one applies for your other graphs as well. So this one over here, what can you say about the line? What can you say about this value over here? It is constant. So the line is constant. Next one. So this one over here, your line is going higher and higher as the time goes by. So your line is increasing. And as for the rate, as you can see over here, after every second that has passed by, so let's say this is 1 second, say this is 2 seconds, say this is 3 seconds. Can you see that the gap between the lines are getting bigger and bigger? So as a result, your line is increasing at an increasing rate. So another way for you to check for your answer, right, is for your line, the word in front of the rate will correspond to the gradient. So as you can see, gradient is increasing, therefore the line is at an increasing rate. Last one over here. So let's say this is T1, let's say this is T2, let's say this is T3. Can you see that after every second that has passed by, the gap between the dotted lines is getting smaller and smaller? So as a result, the line is increasing at a decreasing rate, because the gap is getting smaller although it is increasing. So last description that I'll be going through today is your area. So for your area under the graph, think of it this way. So let's say I got t equals to 1. My area under the graph will be this portion. And then for t equals to 2, my area under the graph will be this portion. And then for t equals to 3, my area under the graph will be this entire portion over here. So for this graph over here, the area is actually increasing at an increasing rate. So whenever you have a graph that is upsloping, your area will be increasing at an increasing rate. Next one over here. So the area under the graph, what happens to it? The area under the graph is actually increasing, but at a constant rate. Because for every second that has passed by, the increase in the area will just be one rectangle. So something like this. So your area is increasing at a constant rate. Next one, so your graph is sloping upwards, which means that your area is increasing at an increasing rate. Same one for the last one. So your graph is sloping upwards as well, so your area is increasing at an increasing rate. So something like this. Alright, let's move on. So next one. So for your displacement time graph, there are two things that you will be able to find out from your graph. One of it is your displacement, the other one is your velocity. So how do you find your displacement? All you need to do is just take the time. So let's say this is t equals to 1. You dot up and then you dot across. This will be your displacement at t equals to 1. And then maybe for t equals to 2, it will be dot up, dot across. So it will be this portion over here. Next one, to find your velocity, all you need to do is just find the gradient of this line. So to find the gradient of the line, you need to calculate your rise divided by your run. So pick 2 points and then do your y2 minus y1 over x2 minus x1. So this is your gradient, which will be exactly the same as your velocity. So when you find your gradient, it is equal to your velocity. So let's go through some of the description of the graphs for this portion. So let's say I have this graph over here. What can you say about the displacement? So the displacement is by reading off this value over here. So you can say that your displacement is constant, because your displacement doesn't increase. Your line is not going upwards. Next one, your gradient of the graph is 0 because it is a horizontal line, which means that your velocity is 0 as well. Next graph over here. So as you can see, your line is sloping upwards. So if it's a straight line, your gradient will be constant. So gradient is constant, which means that the velocity is constant. As for the displacement is increasing after every second. So your displacement is increasing. So as a result, your displacement is increasing at a constant rate. Because after every second that has passed by, the gap between the dotted lines is the same. Or another way for you to think about it is by looking at the gradient. So if your gradient is constant, that means that the word in front of the rate for your displacement will be the same. So it will be constant as well. Next one over here is your displacement time graph. So your displacement time graph, as you can see over here, so maybe I'll label this as t equals to 1, t equals to 2, t equals to 3. So after every second that has passed by, can you see that the gap between the dotted lines is getting bigger and bigger? So as a result, for this line over here, your displacement, which is your line, is increasing at an increasing rate. Next one, So your gradient over here is curving upwards. So think of your gradient as the steepness of the line. So as you can see, the gradient is getting steeper and steeper and steeper. So your gradient is increasing, which means that your velocity is increasing as well. Last graph over here. So this one over here is a displacement time graph as well. So S is displacement. So as you can see, after every second that has passed by, the gap between the lines, right, it gets smaller and smaller and smaller. So this is the first gap. This is the second gap. So the gaps are getting smaller. So your line is increasing at a decreasing rate, which means that your displacement is increasing at a decreasing rate. Next one. So your gradient of the line represents the velocity. So think of your gradient as the steepness of the line again. So your gradient over here is actually getting gentler and gentler, which means that your velocity is decreasing because your gradient is decreasing as well. This one is important. So let's move on. Last portion. So the last portion over here will be your velocity time graph. So for your velocity time graph, there are a few things that you need to consider. So you need to consider the line, which represents your velocity. You need to consider the area under the graph as well, which represents your displacement, and the gradient, which represents your acceleration. So same thing as the previous ones, you will have to think of your gradient, your area under the graph, as well as your line, and try and describe all these three things. So let's take a look at this first graph over here. So your velocity, as you can see, is constant all throughout this journey. So velocity is constant. Next one, let's think about the acceleration. So your acceleration is the gradient of the graph. And the line over here is a horizontal line. So the gradient, which is equal to rise over run, your rise is actually 0. So your gradient is 0, which means that your acceleration is 0. Last one, it will be your area under the graph. So for your area under the graph, after every second that has passed by, it is just an increase in one rectangle. So your displacement, which is your area under the graph, is increasing at a constant rate. Okay, let's move on. So this one over here, your velocity time graph, same thing. So if it's a straight line, your acceleration is constant. So because your line is sloping upwards, your acceleration is positive and acceleration is constant. Next one, your velocity. So as you can see, after every second that has passed by, the gap between the lines is constant. So as a result, your velocity is increasing at a constant rate. Last one will be your area under the graph. So for your area under the graph, if it is upsloping, your area will be increasing at an increasing rate. So your displacement is increasing at an increasing rate. Next one over here. So now your graph is downsloping. So if it's downsloping, your gradient will be negative, and because it is a straight line, your gradient is constant. So your acceleration is negative and constant. Next one will be your velocity. So for your velocity, as you can see, after every second, the gaps between the lines, right? Same idea. So the gaps between the dotted lines, they are all constant. They're all the same. So your velocity is decreasing at a constant rate. Last one will be your displacement, which is your area under the graph. So if it is downsloping, your displacement will be increasing at a decreasing rate. Because after every second, let's say t equals to 1, your area is this, and then t equals to 2, your area is this. So the increase is getting smaller and smaller and smaller after every second. This graph over here, so same thing, your velocity, after every second, the gap is getting smaller and smaller and smaller. So your velocity is increasing at a decreasing rate. Next one will be your acceleration. So for your acceleration, think of it as your steepness of your line. So your steepness of your line is getting more and more gentle. So your acceleration is decreasing because your gradient is decreasing. Last one will be your displacement. So if it is an upsloping graph, then your area under the graph will be increasing at an increasing rate. So same thing, your displacement is increasing at an increasing rate. That's all you have to know for this portion. And then we have one more graph at the back over here. So this one over here, your graph is upsloping and your steepness of your line is getting steeper and steeper and steeper. So your gradient is increasing, which means that your acceleration is increasing. Next one, it will be your line. So as you can see, after 1 second, 2 seconds, 3 seconds, maybe 4 seconds, the gaps between the lines are getting bigger and bigger and bigger. So as a result, your velocity, which is your line, your velocity is increasing at an increasing rate. Last one will be your displacement under the displacement, which is your area under the graph. So for your upsloping graphs, your area under the graph will always be increasing at an increasing rate. So displacement as well will be increasing at an increasing rate. That's all you have to know for this portion, and make sure that you know how to describe all these different graphs.